Hello and welcome to Connect. I'm your host, Randy Shabilo. Today we'll have Charles Renny, an automotive journalist, talking about the future of vehicles, as well as John Danilou talking about cannabis legislation in the workplace. As always, we'd like to connect with you.
Tweet us at connect_YXZ. Follow us on Facebook to watch new and past interviews, or email connectyxz@gmail.com with any future guest or topic suggestions.
Charles Renny is the past president of the Canadian Automobile Journalist Association of Canada. He's here with us today to give us some insight into what's happening in 2018 and the upcoming year in terms of automobile advancements. Charles, thanks for making time for us today.
Oh, you're more than welcome, but I'm going to correct you on one small thing.
I know.
A lot of these developments are coming out in 2018, 2019, but they're going to carry us much further into the future. It's an entire direction that the automobile industry is going in.
Well, then let's talk about that, because a lot of people have, just in Coffee Row are saying, have you seen the new, or do you know about the new, or how many miles can you get on your charge? That conversation's creeping in a little bit more than it has been about fuel economy, but it's electric fuel economy. Talk a little bit about that.
Well, first off, you have to accept that there's several different types of electric power out there. At the very top of the heap is the full electric car. There are no connections to a gasoline or diesel engine whatsoever. You plug it in at night or whenever you need to, and it runs on electricity. There's another one that's just a step down, that's an electric vehicle, but it has a charging engine on board. The wheels are only powered by electricity, but there's a little motor, usually a 1.1, 1.2 liter engine, that will charge the battery when it gets low, so you can actually get around. Then there's plug-in hybrids, which are hybrids. They have a gas engine or a diesel engine that can actually power the wheels or charge the batteries, whatever needs to be done, as well as being able to plug it in at night to top up the charge. Then there are what we just call hybrids, which the gasoline engine or diesel engine is responsible for everything. It's the charging device, it's the motivational device, and the electric engine is just an assist. Helps you going up hills, it helps you around town. You may be able to run 10 or 15 kilometers on the electric only if you stay below 35 to 50 kilometers an hour. That's sort of the range. That's what we've got now. The high-end ones, things like Teslas and Cadillacs, and actually even some of the lower-end ones, Kia's been working on a full electric vehicle. As a matter of fact, Kia is working on a system of inductive charging. You could go to the mall, park in your selected parking space, put your toonie in the meter and get X number of electrical volts pumped into your Kia without even plugging in. It's just inductive like you do with your cell phone. Charging stations are the big issue for anything other than a regular hybrid, because you've got to have one put in at home. You're going to need one on the road if you're going far. If you've got a regular plug-in hybrid, of course, that's not a problem. You've got a gas engine. But if you want to drive your Tesla from Saskatoon to Vancouver, you better plan your trip pretty carefully.
So talk a bit about that then. If we have, I go to work on a job site that doesn't have a parking stall, it's a construction site as an example. What happens then? I have to plan my number of kilometers to know that I can get to work and back home. Plus,
if you're driving a full electric, that's what you'd have to do. Or you'd have to convince the boss that you really need to have a charging station there, and somehow you've got to get a 240 volt charger.
What would it cost of installing that?
Oh, there's a huge range. My standard joke is that if you're in old parts of Riversdale where they still have a 70 amp service, the charging station's probably going to cost you $1,600, and if you're charging your car, you won't even be able to use your microwave.
Sorry, taking all the power.
Takes all the power, the startup power. If you get into a newer area where there's a 100 amp service in the house, or a 200 amp service, as a lot of the new ones are, it's a lot easier, but there's still that same anywhere from $1,500 to $2,000 cost, because it's a 240 volt charger. It requires, of course, a much heavier cable, a lot like your dryer, because it runs at about 40 amps. If your basement's finished, you got to figure out how to get it to the garage or wherever you're going to charge your car. If you live in a townhouse or a condominium that has its own power meter, do you have enough juice to do that? And if you rent an apartment, I'm sorry, you're out of luck. You're going to have to plug into your winter plug-in, which is 15 amps. You're not going to be able to use a special charger, and it'll take anywhere from 12 to 15 hours to put a full charge back in your car. So just think, you can drive your car every 2 days.
So when it is wintertime, and let's take that electric vehicle, it's going to be drawing power to heat that car.
Yep.
That would reduce your range, I suppose.
It does and it doesn't.
Percentage.
What happens both to your car battery and in a full electric vehicle, the battery when it's cold doesn't have as much power. One of the byproducts of using the battery is heat. When you warm the battery up, you bring the power levels up. So if you use that battery just to go a block, it's never going to get warm. But even in Saskatoon, if you were to drive from your place of residence and your car is outside and the battery is cold, you will have more power available to you by the time you get downtown than when you started out. So yes, you can run into a distance problem, because yes, you will have a reduced range, but it isn't like cut in half. If the range in theory is 160 kilometers and you start out with that, when you leave home in the morning with a battery at 25 below, it may say that you've only got 70 kilometers distance. You drive 20 kilometers to work, you get there, you still have 70 kilometers because the battery's warmed up. If you then let it sit all day, it may say you've got 50 kilometers, and by the time you get home, you've got 80 kilometers. It's all in the temperature of the battery.
What happens when we have a vehicle? Are there efficiencies in terms of the price point on the cars or trucks themselves, or the hybrids versus electric, or does a straight gasoline-powered automobile still come out ahead in terms of actual cash outlay?
That depends on the cost of the electricity, actually. In Ontario, they have quite high electrical rates. It's pretty much a wash between electric and gas. Of course, you can bring it down with a combination. In Saskatchewan, gas is right up there. Electricity has a bit of an edge, but our problem is winter. That takes away a lot of the advantages of an electric car. The best vehicle, in my mind, if you want to help things out, is to buy a plug-in hybrid. Those are the ones that have the most versatility, the most range. You can drive from Saskatoon to Eston and back and not worry about getting a charge for your car, because it carries its own onboard charging system. If you are just going to use this car in town, maybe a Mercedes-Benz smart car that's full electric will do the job, because they will do 100 kilometers. Or a Ford Fusion or Focus EV that have 160 kilometer ranges will be the vehicle for you. It depends on what you're going to do with the car. Right now, if you only have one car, you need it to be the most versatile thing you've got. It's got to be able to haul groceries, kids, put a grin on your face, get you to the mountains to go skiing and whatever. When you have enough disposable income to have a second car, decide what you're going to do with that car. Then you may be looking at things like hybrids.
Price points on entry-level electric versus hybrids?
They tend to be a bit more, anywhere from $2,000 all the way up to, I'm going to say about $5,000 or $6,000 for a hybrid, the difference. But it's deceiving, because when you get a hybrid, you never get it on an entry-level, unoptioned vehicle. So they may charge you $2,500 for a hybrid, but they toss in power windows, a few other heated seats, and a few other things. So if you look at those and take those out, or look what they cost as standalone options in some cases, that hybrid package is quite reasonably priced. Maybe the hybrid itself, they're only charging you $1,500 for, and the rest of it's just upselling you comfort in your new car.
In terms of the batteries themselves, do we see any types of advancements in what they're made of, or how they're disposed of? And
well, Disposal is still an issue. The manufacturers handle that right now. Improvements, yes. The first batteries that came out years ago were nickel metal hydride, and they developed a memory over years. And they were larger and they were heavier, a lot more difficult to handle. We've now seen a switch to lithium-ion batteries, rare earth minerals, because they're looking at lanthanum, they're looking at a series of other metals that will do this. They've now packaged them as individual cells, and they're dry cells. They're like a gel, and they're hooked in. So if you have a problem with your battery, your local dealer still can't fix it, but they can remove the unit, send it back to the factory, have it refurbished and sent back. And in the meantime, you've got somebody else's rebuilt battery. It's like when you're buying a remanufactured engine for your car to put in. You've got something from somebody else that the factory has fully gone through, made it like new, and is putting it back out. It's the same for disposal. Right now, what you and I would do is we'd go to the manufacturer. They would swap the unit out, and the old one goes for repair or recycling. If it's a total loss in a car, that brings up several other issues, because recyclers are very interested in rare earth minerals, because those have a big value. So they will take the battery pack out and sell it back, sell it on, and the rest of the car just goes for scrap. It often has a lot more copper in it, because these battery packs often operate at 400 to 600 volts, which brings in the other part of it is if it's in an accident, how safe is it to be in? Well, there are sensors in the battery pack that if it senses an impact severe enough to, let's just say, set off the airbags, it drops a safety switch, and the battery is contained. If the battery pack itself is ruptured in the accident, it's going to be serious enough that emergency services are going to be there, and fire departments have spent thousands and thousands of dollars of training on how to handle these. They have special equipment to handle high voltage situations, so they use it in cars as well as in regular fires. Just to go to the racing world, there's what they call an e-racing series, and they have special insulated poles and a guy in a full insulated suit, so that if something goes wrong with the battery pack and one of the guys touches it, they can use this pole to move him away from it without hurting anybody else. So yeah, you've got to handle them specially.
Charles, you know, we could talk for hours about this. It's amazing to keep hearing from you what's out there and what's coming. I want to thank you for making time for us today, and been an electrifying experience with you.
Well, we can do this again, because we've just scratched the surface of what's coming down the line.
That's perfect. We'll be right back.